So, my name is Pavel Konstantinov. So, I'm an assistant professor from Moscow State University, and I provide urban climate research all around the world. It's about 15 years. So, that's why I think for me, it's a great pleasure to see you all young professionals. And I think our session will be very fruitful. And I would like to make you know that between existing parts, there will be two teams. There will be two teams, the team from Moscow State University and the team from Ranepa, but it will be not any competition between these teams. So it's it cannot be any competition between right hand and the left hand. So they ought to work together and it will be the good for the good result. So I will try now to share my screen for the inviting talk about urban climate problematics. And after we will start our session, I think in tentative program that you already have. So I will try to share my screen. Now I hope everything works good. So I will try to be brief because the problem of the cities and climate change, I think, is quite close to every one of you. And that's why I would like to be deep in the history of this question, because I think it's could be interesting for someone of you. And I will begin from the climate and society interaction, because about the interaction and the influence of the society on climate change, we know now everything, and we can hear it from the newspapers, from the TV news, from the World Wide Web, and so on. And what's about if the interaction, the influence of the climate to society, and not the modern society, but I think about the European society of the past. So, and I think the first interesting event will be the year without a summer. It's the year after the biggest volcanic eruption during the last 1,000 years. So it's the eruption of the volcano Tambora in Indonesia. So the island of Tambora now is ruined, and everything was ruined during 3 days of this eruption. And you can see I found some interesting comments from the wiki about the consequences to the European climate. So I think the famine was prevalent in North and Southeast Ireland. Also, the problems of summer weather in Switzerland. Also, the problems in Great Britain. And you understand that this event was after the few years of the Napoleon Wars in the whole Europe. So the Europe was a little bit ruined also. If we will take a look to the to this graph, we will learn that this year, the year without a summer, is one of the coldest years during the last 1,000 years. Also, it was the social consequences. So, of course, the people should decide to go to the USA, and it's one of the USA immigration waves after the common influence of the Napoleon Wars, after year without a summer, the famine, and so on. So you can see this picture about Uncle Sam. He's a bit surprised because what happens, but it's also one of the consequences of this climatic catastrophe, of this climatic event. Also, it was the cultural consequences. Mary Shelley has the time to invent and to write it until the end, the story of the Frankenstein. There's Frankenstein of the modern Prometheus. It's one of the first horror romance, and here I found for you this poster. It's the poster of the first horror Frankenstein in history. So I think you have heard a bit about this book or this movie. It doesn't matter. So, and this let us know that the interactions of the climate and society are very close and can be very different. Why do we need to learn urban climate, the climate of cities, the influence of cities on the global climate, and so on? And let's, after these horror movies, let's have a little bit of humorous. So at first, it's beautiful. First, it's beautiful, and in this picture, you can see one of the maybe the most beautiful connections of the urban climate. It's the influence of this building structure in Florida, in Panama City Beach. You can see that the humid air that needs to go up is form such kind of the tsunami. So the tsunami cloud. So of course it's not dangerous, and but without any urban influence, we never saw it. If we will keep an eye to the typical urban climate problems, we will see that 90% of disasters for urban areas are typically have the hydrometeorological nature. So you can see, we can see here the urban heat island, local air pollution, regional acid rains, the heavy rainfalls, and something like this. And what do we need to do? Of course, we need some mitigation, adaptation, and have the systems of the early warning, because the people should know that upcoming rain can be dangerous, especially for some parts of the urban areas. And very well known graph, the graph about the urban and rural population dynamics. So there are about 10 years that we are now living in the urbanized world. So now the urban population is about 51.5% of the whole population in the world, and that point that the urban populations goes to the and make more intensive that the rural population is about in 2010. In 2010, and we know that 2010 it's also the year of the Great Russian heat waves that have the big influence to the climate and to the health of the citizen of the Moscow megalopolis. What do you know? How do we can learn something about the urban climate? For this task, we need to use a WMO station network. WMO, it's a World Meteorological Organization, and here on this photo, we can see the traditional meteorological station. It's a meteorological station from Moscow. It's a main meteorological station. It's close to the VDNH area. So this network contains now about 40,000 of stations all around the world. And if you keep an eye to the picture of a WMO station in Arctic, it's a Norilsk region. We can see here that all WMO meteorological stations looks the same way. The density of such station is not permanent in the different points of the world. You can see that in Western Europe, in the southern USA, in the Guinea Gulf, also in the Eastern Asia, but in Russian Siberia, for example, in the Arctic Canada, we have very poor density of such stations. That's why we need to use maybe some citizen observations, the citizen networks, for observing the traditional microclimate variation of the weather and climate in cities. And for example, urban heat island, you see this canonical picture. That's the big buildings and the very high building density in the center of city can create urban heat island. The urban heat island is a main phenomenon of the urban microclimate. And this urban heat island can have the influence into the catastrophic climate events like the 2010 heat wave. These heat waves, of course, forms very hot conditions, and the exceptional heat for this such long duration, also combined with the poor air quality from wildfires, increased the deaths at least 11,000 only in Moscow. 11,000 of people. So it's the population of the small Russian city, for example. First urban climate study that was performed 200 years before. It was performed in London, and you can see the first page of this book. So it's a climate of London deduced from meteorological observations, and the author was Luke Howard. And here we also can see the first urban climate graph that let us know that the cities is always in each season warmer than the rural area. And generally, it's the main idea of the existing of urban heat island. Also, if you are interested about Luke Howard biography, so you can also find it in Wiki and see that the picture of Luke Howard personally. Now we have very good measurement systems for measuring urban heat island and so on. And also we can have the urban thermal comfort assessment. And also it's also for the end of my inspiring talk, there will be the funny idea to use this good study about the studying of the King's Landing effect. It's to modeling the virtual city, not the real city like Moscow, Paris, London, and so on. So it's a modeling of the climate of the fantastic city, and this fantastic city was the King's Landing from the Game of Thrones. Game of Thrones, you know, it's a very well book by George V. Martin. Also, I think you're familiar with this movie. And this imaginary city, King's Landing, was intervened into the modeling area. And after having the climate initial conditions of the city of Dubrovnik, Croatia, because you see that Dubrovnik looks similar with the King's Landing pictures. So we can also model the microclimates of these virtual cities, but it's not the main point of my talk. Please be attentive. So finally, if we can modeling this virtual city, we can modeling the social effects of these cities. And take a look. So excessive heat load can be formed in the socially privileged areas as a result of the natural and human-induced factors. So, and the basic mechanism that relates social inequalities with environmental problems, it's that in naturally advantageous areas, they can maintain good quality of life, and in less favorable areas, it's impossible to maintain such quality of life, and the microclimate and the thermal comfort conditions are going low. It also can be this King's Landing effect in the urban climatology can be found in the real cities also. From this slide, you can learn that the correlation between urban heat load in the capital of Austria, in Vienna, and the real estate prices, so they have very good correlation. It's also that the King's Landing effect can be found in many capitals of the world. So it's another one idea that I would like to share with you, that the urban climate and the social problems and the some financial mechanisms, they are very deeply connected in these small urban areas. That's why, and I would like to now to say you the floor is yours, and to begin our session. But another one, maybe my final note, that I would like you to be very active. Please, if you are interested in something about the talk of your colleagues, please ask everything that you are interested in, because we are here for the interacting and for having the not for competition, have a competition in our reports, but also for finding maybe the new connections and trying to have the conversation between the people who are experienced in physical mechanisms of urban climate and the people that are experienced in some social and the administrative tasks. And I think we will have very fruitful session. Now I would like to ask Andrei Shanov. Andrei, are you ready now?
Sure, Pavel. Thank you. And I would like to
greet. You are ready, so the floor is yours, so you can begin.
Thank you. Thank you very much. First of all, I would like to greet my fellow participants and all our viewers for joining us today. And we have to understand that urban climate is not just a buzz topic, not just a hot one, but it is an issue we must acknowledge, because in the future it will become more and more prevalent. And the sooner we understand its importance, it being crucial to us, the better understanding we will have of it, and more opportunities to change the world for the better will be at our disposal. With that being said, please, could you switch to the next slide? Yes, the topic of my speech will be the urban climate in post-pandemic cities. Yeah, sure. The thing that is heard just around every corner, COVID-19, the pandemic, and all its devastating effects. Now let's focus what the COVID-19 has brought to cities, to urban areas. Now, it goes without saying that COVID-19 has brought a lot of suffering, damage, destruction. But are there any positive sides to this pandemic? Turns out there are. If you pay your attention to the slide, the air pollution has dropped dramatically. Specialists all around the world say that the air quality has drastically improved, and all thanks to the COVID. It has improved in the COVID-19 hotspots, such as China's Wuhan, Italy's Milan, New York, and Los Angeles in the USA. So, at the very least, in these dark and gloomy times, there has been some positive, with air pollution dropping down and air quality going up. On average, there has been reduction up to 30% in the contamination of air in cities around the world with such molecules as nitrogen oxide, sulfur dioxide, and carbon monoxide. Unfortunately, there has been some there has been some drawbacks for ecology as well. We began to litter more. Well, generally we stay at home nowadays more and generate much more plastic waste. That's a downturn. Even though the quality of air once again has dramatically increased, on the other hand, we produce a lot more rubbish, and we'll have to deal with that in the future as well. Because with all the medical supplies that we use daily, the masks, the gloves, the syringes used for vaccination, they are not going to go in a way in a blink of an eye. We're going to have either to dispose of them or to recycle them. But sadly, not a lot of people are talking about that. And lastly, let's pay our attention to the use of public transport. So experts say it has gone down, the use of public transport, but instead we began to use more individual vehicles. So with the pandemic, with the social distancing practicing, people all around the world tend to use individual vehicles to commute. That in turn actually is not beneficial for the air pollution, and who knows, maybe in the future it will backfire. But we are getting back to the topic, and I would like to switch to the next slide. Thank you. Now let's just look at the statistics. The few cities around the world, just as I mentioned earlier. So the hotspots that have been mentioned, the Milan in Italy, Madrid in Spain, New York in USA, and Delhi in India. All of these cities have a large population, a lot of people commuting and using public and individual transport daily. And it is because of it is fossil fuel combustion that causes most of air pollution. With that gone, just in 4 weeks, just in 4 to 6 weeks since the lockdown has been imposed, the concentrations of nitrogen oxide in the air has been gradually, steadily dropping down. And that's a pleasant thing to see, that even after the lockdown has been lifted, in the post-lockdown period, there at least been stagnation, not a rise, no spiking, but just stagnation of concentrations of nitrogen oxide in the air. That perhaps is a positive trend. Hopefully it will stay the same way in the future. Once again, key aspect here, in just that short amount of time, the quality of air has just increased dramatically, and the concentration of pollutants in the air has gone down about 2 to 3 times in major cities all around the globe. Next slide, please. Has it always been like that? Have there been precedents in the history? Well, there have been, but nothing as major as the COVID-19 pandemic. If you look at the statistic on the left of the slide, you can see that during the times of World War II and the previous global recessions, there indeed were drops in global carbon emissions, but nothing as prominent, nothing as huge, and nothing as major as the global pandemic of 2020. The hugest, the biggest drop in global carbon emission was in the year of 1983, and it amounted to 1,000 tons of carbon dioxide. Nowadays, it amounts to more than 2.5 tons. You see, the gap is just enormous, and this speaks volumes. And one more prominent example for you. We all know, dear guests and fellow speakers, that China is notorious for its air pollution. And just in 20-day span, I repeat, just in 20-day span, the levels of nitrogen oxide in the air above Wuhan decreased to almost negligible concentration. Can you believe that? So, with all the talks about the global warming, how much we contribute to them with the greenhouse gases, it is possible actually to stop that tendency if we do not use transport all that much. And it turns out all it takes is to have one major pandemic. With that being said, we are finishing with the part of dedicated to present climate situation, and we are moving on to the prospects to the green resilient recovery. Next slide, please. So, what does resilient green pandemic imply? The COVID pandemic was a shock to everyone. It disrupted our way of life, our everyday flow of life. You see, there is a point of disruption, so-called shock. And once we are past it, there are 3 possible ways of further development. We can either just survive, accept it, and try to move on further, but it leads to loss of livability and sustainability. We may recover, do it more efficiently, but still it will do us little good. Instead, we should opt for resilient development. How can that be done? It can be done when all the stakeholders, the society, government, local government, academia, and think tanks all come together to think of ways of a resilient green economy. That implies all the needed practice to tackle the already existing pressures, such as the depletion of resources, such as the global warming and all the others, as well as not letting such disruption as COVID occur again in the future. There are 3 main components to this resilience economy: the mitigation, adaptation, and transformation, all listed in the picture, all elaborated in the picture in the slide. Key point here is bringing the stakeholders together. Once we acknowledge that it is in our power to stop the vulnerability to disruption, then we may actually switch to green, resilient ways of sustaining the economy. That would mean water resilience, relying heavily on natural systems, and so on. In the interest of time, we'll stop with that topic and actually go to to the ways it can be implied. And it is there described in the next slide. Thank you. So, have anyone heard about the 1000 Cities Initiative? It is an initiative dedicated to bring the communities of cities all around the globe, hence the 1000 cities, the 1000 largest ones, to actually switch to green resilient economy, to raise the public awareness of the issue. For the local governments, it is to encourage people to switch, encourage businesses, and to switch to resilient, eco-friendly practices, eco-friendly way of leading a life. And that, in turn, would allow us to prosper in the future. If we decline that, if we do not pay much attention to it and neglect that, well, chances are in the very foreseeable future, just in a few dozen years, we will not recognize the world we have today. And it is this 1000 initiative, as well as other environmental initiatives and organizations, such as the ones listed on the slide, UN Habitat, Sustainability Solutions Group, and Pathway to Paris, that promote the idea of green, resilient economy. With that being said, I believe I'm coming to a conclusion of my presentation. I hope I've managed to convey my point of view that it is in our power to change the way we live, and it doesn't take a pandemic in the future to stimulate that way of life. No, we can do it ourselves. And let's hope that there won't be any other COVID-like problems in the future. But still, this one dire experience was enough for us to learn from our mistakes, and in the future to enjoy the beautiful urban environment and the urban climate that we and our children can enjoy. Thank you. I see there are a lot of questions in the chat.
Yes, Andrei, thanks a lot for your inspiring talk. So you see there are the question from the Alan, and now we have the time for at least one question. So Alan, can you ask your question by yourself?
Yeah, that would be actually a bit more comfortable for me. Well, there are two questions I would like to pose, and I think the second one is a bit more focused on the topic. How viable do you think these green solutions are? After all, the green solutions right now seem quite costly. So in a post-pandemic crisis world, how viable is the implementation of these policies? Will it be, or maybe it will be a lot easier to choose something that is cheaper and faster?
Of course it will be. It will be tempting to choose something cheaper and faster. The only question here, at what cost? You see, if we neglect this idea of opting for more expensive, more demanding ways of sustaining the economy, sustaining the cities, we just risk the near complete exhaustion of resources, and we risk the very prospect of our cities remaining the way we know them today. So basically, it is a choice of whether to enjoy the current moment, not give care about what happens in the future, and that will lead to dire consequences, may I assure you. Or we can actually try and do the right thing, the hard thing. Yes, it will be costly. Yes, it will require a lot of effort, but I believe it is the only way. The other alternative, the only other alternative, is not pleasant at all. It will be the degradation of ecosystem, of the decline in the quality of life, and so many other negative repercussions.
Thank you very much.
Okay, guys, thanks a lot. We need to go further. So, and The next speaker, if I'm not mistaken, will be Alena Lobachova and Polina Aperian. So about the effect of climate change on labor productivity. So are you ready?
Yeah.
Okay.
So good evening, ladies and gentlemen. I'd like to quickly introduce my colleague and myself. My colleague is Polina Aperian and I'm Alena Lobachova. We are fourth-year students from IBS Ranepa. We are going to talk about the effect of climate change on labor productivity. Our talk will be in 4 parts: which changes will affect workers, types of impacts, urban head cost framework, and situation in different areas in future. So Polina, please start.
Thank you. So the productivity of urban workforce depends completely on health of workers and the condition in which they work. The projected health impact of climate change will be mediated by appropriate medium and long-term trends in both climate and weather, including seasonal, random, and long-term events from the next few years to several decades in the future. Current research indicates that health impact will arise through increase in the frequency and intensity of extreme weather events and through factors associated with progressively higher average atmospheric temperature. Due to changing perception characteristics, some regions will become drier and others will become more humid. And in addition, increasing the amount of rainfall is likely to happen by increasing the rate of serious ones. So the resulting of mutual influence and modulating effects on the local level will lead to larger number of potential impacts on persons' physical and mental health. And it could have an impact on performance at all. Yeah. A wide range of foodborne and waterborne diseases are sensitive to average temperature and rainfall. The greatest effect will be aggravating and of existing diseases, especially among a vulnerable population. It could be people higher than 65 years old. Heat waves can further increase the formation and stay time of air pollutants, leading to additional effect on cardiovascular and respiratory diseases. Cardiovascular diseases directly affect our energy, and the characteristic side effect of this disease are increased tiredness, sleep disorders, and these symptoms significantly reduce productivity and affect most of working population. Moreover, scientists have found that our brain are sensitive to changes in temperature. And this statement has been confirmed by many experiments. In hot environments, the performance of the subject decreased by 13%, although temperature difference was almost 5 Celsius. Besides to the person, the weather and especially the increased amount of rainfall in cities will significantly affect the transport and infrastructure used by workers. A large number of rainy days will complicate the traffic situation with traffic jams, accidents, and other difficulties during commuting to the work. And this means that employees will arrive at work already tired, irritated, and the level of stress will significantly reduce their productivity at the beginning of the working day. Alena, thank you.
Thank you. So next, we would like to show how it's possible to estimate the decrease in productivity of individual workers due to psychological head stress, based on international standards that use the wet bulb globe temperature. So the WBGT is a combination of 3 measurements: the natural temperature of a humidified thermometer exposed to wind and heat radiation on an object, the temperature measured inside a black ball, and the air temperature measured with a conventional thermometer protected from direct thermal radiation. So we define labor productivity as the proportion of the working day during which an employee can perform work in various thermal conditions. Labor productivity at a given labor intensity is a monotonically non-increasing function of the temperature of the wet wall between the upper and lower boundary. So above the upper bound of the WBGT, labor productivity is 0, and below the lower bound, labor productivity is 1. The estimated losses due to heat stress and labor productivity are not negligible. In a warm year in the distant future, they're estimated to be about 0.4% of GVA, in London, 2.1% in Antwerp, and 9.5% in Bilbao. On the slide, you can see what the losses in euros will be. Losses vary greatly by sector depending on the structure of each city. For example, while in Antwerp, losses in the manufacturing sector amount to 24% of all losses, in London they're only 6%. Losses in the financial sector amount to 24% of total losses in London, 20% in Antwerp, and 19% in Bilbao. Without climate change mitigation, daily average outdoor labor productivity could decline by around 10 to 15% from present day levels by the end of the century. So therefore, it's worth developing a strategy that is easily portable from one city to another and can adapt to specific urban conditions with relatively modest data requirements.
Yeah, that's all for our presentation. Thank you for listening, and we are ready to answer your questions. Please feel free to ask them.
So Alona and Paulina, thanks a lot. So if anyone has a questions, you can raise your hand in Zoom. You see there are some where you can switch to the raise your hand, and or you can write your question, or you can write that you want to ask the question in our chat, and I think we will find the best way to let you speak. So, and so I think I will begin. And I think it's very good that you choose WBGT for your study, because WBGT is the very good index for using it worldwide, especially in Russia. Then we have, the climate that is not similar to climate of London, for example. Yeah. And my question was, can you show the previous slide of your presentation with the, about the estimated losses? Does this kind of losses includes the impact of the raising of the mortality to the end of the 20th century according to the heat stress, or not?
I think not, because it's it was numbers only for the labor productivity, and I think mortality will be more in the 65 plus people, the age of 65 and plus people. So it's not the labor productivity level. And so no, only with the so I think here we choose only the people from 20 to maybe 55 or 60, and their main problems will be in diseases and or stress and mobility problems.
Okay.
So Have I answered your question?
Yeah. So any other questions? So in this case, I think my second question is, do you know that the WBGT has a very interesting area than the different countries are using it. WBGT is using by the US Navy forces, the Navy SEALs, in tropical areas. So if you have ever seen the movie like The Soldier Jane and so on, so it's the decision, it is possible for a soldier to training on the fresh air is getting by the WBGT index, for example, in tropical areas and in tropical Navy bases and so on, especially in US. So it's maybe interesting thing. Okay, so thanks a lot. And now on time, I think we need to go further. And I would like to ask Alen Kospanov to share his screen.
Yeah, thank you. Good evening, ladies and gentlemen. My name is Alen Kospanov, and I represent the Moscow State University. I study at the Faculty of Geography in the Department of Meteorology and Climatology, and today I would like to present to you my little research that was focused on the theme of microscale modeling of thermal comfort indices in Moscow. It was a case study of the famous Moscow heatwave of 2010. Next slide, please. So let's first focus on the area of study. As an area of study, I have chosen the territories around Balchuk Meteorological Station. This decision was based on two main reasons. First of all, there exists a well-known meteorological station which can provide the needed data for the implementation in the model, so that we can use the observations that were made there as our boundary conditions for the microscale modeling. Secondly, this area is comprised of both built-up territories with quite high density of buildings, and also it has some areas with a substantial area of canopy, of tree canopy, like Bolotnaya Square and the areas inside the Moscow Kremlin. That is why it was quite a good area to show the significance of the green infrastructure that it might have on the thermal comfort indexes in an event of the extreme heat wave. And next slide, please. So let's focus on the meteorological conditions that were present at the date of modeling, the 29th of July 2010. That was the day with the highest observed temperature in Moscow, and at the Balchuk Meteorological Station, the maximum temperature was reached at 15 hours at 3 p.m. and reached 38.5 above zero. This was due to an omega block in anticyclone, which transferred a substantial amount of very warm tropical air mass from the Middle East and former Soviet Union parts of the Front Asia to the European plains. And this heat wave lasted for approximately 45 days. So at the height, at the peak of the temperatures, it was already a very long period of prolonged heat stress. And next slide, please. So how did I do this modeling? How did I do this research? I utilized the EnviMet model. This is a microscale modeling software packet. May I say that includes also a microscale model that is centered around the Reynolds averaged equations of the atmosphere dynamics that you can see here. This microscale model is very useful in producing a very accurate simulation of a city and its parameters, because it has a lot of various ways to define the properties of a building. For example, the various materials of walls and different roof greenings and profiles of soils and surfaces, and also windows. And also it has an improved radiative flux numerical prediction system, so it can produce a very good description of both thermal wind distribution maps and the bioclimatic conditions. And now we will review the results of this study, which are on the next slide. And here you can see two maps of the main meteorological parameters that influence the thermal indices quite greatly. We will not be focusing on the wind speeds that were observed in the city, because in an event of an anticyclone, especially a blocking one, the wind speeds rarely exceed 3 meters per second, which is, well, not that high a wind speed. So the point of interest is the air temperatures and the humidity. Well, here you can see the maps of the differences between the two model runs. In one of them, the trees were as they are in Moscow, and in the second, all of the trees were removed in the model. So it produced a blank simulation without any green infrastructure. And here you can see the difference in air temperature observed and the specific humidity. You can see that the decrease in the air temperature under the tree canopy can be up to 6.5 degrees Celsius. And unfortunately, the trees transpirate a lot, which produces an increase in the specific humidity. And the effects of it we will see a bit later when we go to the thermal indices, which are on the next slide. The thermal comfort. On the left, you see the diagram, the map for the PET, or the physiological equivalent temperature index, for the tree simulation. And you can see a significant decrease in the observed PET under the tree canopy of up to approximately 2 degrees relative to the neighboring streets. And on the right, you can see the PET difference, and the maximum observed difference from the runs with and without trees is up to 3.5 degrees, which is the difference, as you can see from the table on the right, between strong heat stress and moderate heat stress, or in this case, moderate heat stress and slight heat stress. So in the case, in the event of the removal of the trees, our slight heat stress will go up to the moderate heat stress, which is a significant change because it reflects a change in the possibility of being out in the heat for a prolonged period of time, and the effects that this prolonged heat will have on the person that is experiencing it. And on the next slide is a bit of an oversight to the perspectives of this work. Here is an example of mesoscale downscaling. On the left, you can see the available Era 5 database. It is a global reanalysis with the spatial resolution of 9 kilometers, and unfortunately it does not produce a strong urban heat island, about which Mr. Konstantinov talked a bit earlier. And on the right, you can see the product of my own simulation work, and here you can clearly see a strong urban heat island for the case of 12th of July that same year. And how is it useful? Well, you see, in order to produce a microscale simulation, we need to input the boundary condition, meteorological conditions, and they can only be achieved from a meteorological station. Unfortunately, in Moscow, we have only 4 big main WMO stations, Balchuk, VDNH, Tushino, and Moscow State University, and this does not cover Moscow at all. So we need to have a smooth field of the meteorological parameters, so we can choose any point in space and model accordingly. So in this case, the WRF modeling is at 900 meter resolution, which approximately is the size of the domain that is recommended for the NVMet modeling. So the technology is that you produce mesoscale modeling and then use the results as a initial condition for the microscale modeling in NVMet. And on the final slide, you will see the results and perspectives of this work. On the right is a demonstration. There is a relation of a coupling experiment between the WRF and NVMet models. And this experiment will show that it is possible to couple these two models in order to produce the simulation. And the results of this work are that the difference between the runs with and without trees is significant, and the thermal stress under the tree canopy is significantly less. It is possible to couple the microscale model with the mesoscale one, but there exists a very big problem in NVMet. The water properties are really underrepresented because the evaporation and cooling and the processes inside the water itself are not represented in the model at all. So this is up for us to tell whether the effects of the Moscow River will be somewhat accounted for in the future. But for now, we can see that the trees do impact our life very greatly. So it is vital for us to preserve, conserve, and improve the states and the amounts of trees and the green infrastructure in our city centers in order to suffer from less heat stress in a possible future heat wave. That is all, and I now would like to answer your questions. Thank you very much.
Thanks, Alan. Everyone, so do you have any question?
Well, if I may, one.
Oh, Andrei, you are welcome.
Yeah, actually, Alan, it seems Alan anticipated the question with his very last statements about the effects the water bodies of urban areas have on perception of thermal stress. Even if there are no data, even if there are no studies as of now, what are your own predictions of its effects?
Well, I may suggest that the effects of a big water reservoir in an area of Moscow, like for example the Moscow River, will be quite the same as is with trees. It will see a decrease in temperature and an increase in humidity, which will result in a smaller decrease of PET. However, we must also count that for the fact that the trees block the direct sun radiation. So it is possible that PET might actually increase a bit because the temperature might go down, but the radiation will not. And this influences the energy balance of our body on which the PET index is simulated. But I think if we go to the WRF slides, oh no, unfortunately it cannot be seen there. Well, in the WRF simulations, there do exist the effects of the water bodies, and they decrease the temperature by approximately 7 degrees sometimes in the day. Yeah.
And what about the area covered? I mean, even though the water bodies tend to be large, do they affect only the adjacent areas, the banks of rivers, so to say, or these areas rather, or do they cover wider areas?
Just the area, quite directly above the water body. Yeah, not a lot further, like a couple of meters at most. Well, for bigger reservoirs, it could be tens of meters, but substantially not that big a deal, actually. Yeah, not as much as trees.
Thank you, Alan.
So now we have the time for one question. Maybe.
I have a question.
Oh, yes, Elizaveta, please.
I want to ask, did you set the values of radiation fluxes in the MET for your calculations, or you use only the temperature values from the station?
Well, I did use the radiation, but I did it in the form of the cloud forcing. I forced the cloud cover because on the date of 29th, the total cloud cover was 6 out of 8. So yes, that did impact the radiation quite significantly. And the NVMet itself also produces a net radiation by the position of the area. So it has an underlying radiation distribution for the day, and then on it there are some effects from the cloud covers or additional forcings. And here in this work I used the cloud force.
Okay, thank you.
Thank you.
And I think the final question by mine. So, Alain, why did you choose this area significantly close to the Kremlin area for your research?
Well, it wasn't based on the proximity to Kremlin. It was based on the fact that there is a meteorological station with available data, and also Kremlin posed as an area with lots of trees in it, not as an attracting point actually, but rather as a park, as a big park.
Okay, thanks a lot. So thanks a lot, Alan. So now we are moving from the Moscow region to the Arctic region, and Polina Vorotilova will present her study about the inversion in Yamalo-Nenetsky autonomous region. Polina?
Thank you.
Can you hear us?
Yes, did you hear me?
Yes, we hear you. Everything is fine.
Okay.
The floor is yours.
Good evening, dear colleagues. My name is Polina, and I would like to present you my research. The theme is research of surface-based temperature in Nadim according direct measurements and simulation. Next slide, please. First of all, I would like to tell some words about temperature inversion as a phenomenon. Usually, in the lowest parts of atmosphere, temperature decreases with altitude, like on the left figure. But often there are some cases when temperature increases with altitude, like on the right. That situation is called an temperature inversion. Next slide, please. Could you switch slide? Thank you. The most favorable time for inversions formation is the winter, especially in Arctic. The reason is strong radiation cooling of the surface and frequent anticyclone conditions. When inversion forms above the urban zone, it can lead to accumulation of polyton under inversion layer, like on the right picture. And so it can pose to serious danger to people's health. Next slide, please. Urban surface-based inversions in Arctic now are still weakly understood because of poor nature monitoring equipment in the most Arctic regions, and because reanalysis resolution is too low for cities. But of course, you can ask me, but what's the problem? Let's take that not for cities, but somewhere near. Unfortunately, we can do this because there is a special urban feature called urban heat island. It's a phenomenon. It is a phenomenon when temperature into a city more than temperature in rural area. Urban heat island in Nadim was detected during the measurement company UHARC in 2016-2017. Its intensity can amount 7 degrees. For comparison, in Moscow with its huge population, intensity of urban heat island can amount just 10 degrees. And small Nadim with 40,000 people has 7. It's a very interesting. Next slide, please. The main issue was to estimate spatial temporal distribution of surface-based inversions in Nadim according direct measurements and results of numerical experiment. On the slide, you can see tasks of the research. Next slide, please. Research has 2 parts, gradient measurements and numerical simulation. Gradient measurements were carried out in period from 18th of December 2018 to 15th of October 2019. There are 2 gradient complexes installed in the urban zone, museum, Dom Prirode, and rural zone, the airport. Gradient complexes were based on automatic temperature logger Hobo MX 2303 with sensors at altitude of 1.5 and 3 meters. Other technical parameters of measurement you can see on this slide. For each gradient complex, no, please, thank you. For each gradient complex, the value of temperature gradient per 1 meter was calculated. Cases with negative values of temperature gradient were taken as temperature inversions. Next slide, please. The second part is a numerical experiment. It was performed for 2 coldest days during the observation period. For simulation, the mesoscale and hydrostatic model, the FRV version 4, was used. Calculations were carried out for 4 nested domains with common center in Nadim. The obtained data for rural zone was compared with measurements of a microwave temperature profiler NTP5 in rural zone. On the slide, you can see computational domain configuration. Next slide, please. On this slide, you can see distribution of the temperature gradients observed in winter in Nadim, and in the daytime on the left and on the nighttime on the right. Distributions for urban and rural zone have a very similar form. However, in the case of the rural zone, distribution shifts toward stable, more strong, stable stratification that can be explained by effect of urban heat island, which is weekends temperature inversion in the city. At night, both distributions shift towards stronger inversions. This is result of radiation cooling effects. Next slide, please. On this slide, you can see deviations of the modeled profile for 22nd of December 2018 with NTP5 measurements for rural area. The temperature profile deviation is positive all day long. In the second half of the day, temperature has largest error near the surface, and it can be explained by difficulties with modeling of surface layer in stable conditions. Next slide, please. Now you can see conclusions of the research. For the most of the time in Nadim, temperature inversions are observed in 80% cases for day and 90% cases for night. Inversions in rural zone are stronger because of effect of urban heat island, which is weakens temperature inversions in the city. And numerical experiments has shown problems with simulation of stable conditions and necessity to improve simulation accuracy by changing some parameterization of surface layer, I think. Thank you for your attention. I will be glad to answer your questions.
Thanks a lot, Paulina. So, please, questions. Don't be shy. And now on time, my message to you. So, Paulina, and why did you choose the relatively small city of Nadim for such experiment?
This is some reasons. First of all, it is related to his location. It's a subarctical town located on the flat relief. So we can research Arctic city and we can avoid we can avoid orographic inversions. And the second reason is urban heat island, because earlier scientists thought that urban heat island is a result of sunlights. So in Arctic cities, as the scientists thought, it should be small and weak and not isn't interesting. But as I said, in 2016 and 2017, urban heat island in Nadim was detected, and it was very large. So it was very interesting to research Arctic city with so interesting urban heat island.
Okay, thanks. We have now time for at least one question.
Thank you very much, Paulina, for your thorough research and presentation. Definitely well done. The question is, in your speech, you said there was a discrepancy, a difference between the parameters for urban areas and the rural ones, and suburban ones as well. And is the when actually does the difference start? Is it a subtle one, so it changes gradually with the distance between the settlement and the rural area, or is there actually an abrupt a cut in point where the difference becomes apparent?
If I understood, you have asked me about the ways I found difference with urban and rural area. Yes.
Correct. Yeah.
Okay. I have chosen to avoid some mistakes. I have chosen point in the center of the city, so it's clearly urban zone, and I have chosen point which is almost clearly rural zone in the airport with minimum of human okay.
It's okay. I get the point.
Okay.
Thank you very much.
So answer is I have chosen point that clearly urban and clearly rural. So without.
Yeah, reasonable, makes sense. Thank you.
Thank you.
So Pauline, and by the way, so how do you think is this border between the urban inversions and the rural inversions should be well seen, or it should be a little bit smoothed? It's only about your opinion, because of course we couldn't check it.
I think it is. I think there is a difference with European cities and Arctic cities, because in Europe, city can be very can have a very large square, and in Arctic city should have a compact square because Arctic has difficult conditions, very strong frosts. So the answer is that in Arctic you can clearly see border with urban and rural zone.
Okay, thanks a lot, Paulina. Okay, from Arctic we are moving to, one moment, where are we? Oh, to Moscow. So let's returning to Moscow, and the floor is for Elizaveta Nikolaeva from Moscow State University. Elizaveta.
Good evening, everyone. So the theme of my presentation is microscale simulation of wind speed in urban areas during extreme weather events. Next slide, please. So why do we need an operational forecast of dangerous weather events? In the modern world, more than half of the world's population lives in cities. In this regard, people need to ensure the comfort of their stay in an urban environment. Rapid forecasting of dangerous weather phenomena in cities is an important task in meteorology. Lack of timely warning of a dangerous weather phenomenon can cause colossal damage. Next slide. The main goal of this work is to simulate wind fields of various directions for the MSU campus and to find potential hazardous zones. This experiment is carried out according to data obtained at the Meteorological Observatory of Moscow State University during a squall on May 29th in 2017. The tasks set in the work are presented on the slide. Next slide. A squall is a sharp and short-term increase in wind up to 15 meters per second and more, accompanied by a change in its direction. Sometimes gusts of the wind in squalls can reach stormy or even hurricane speeds, as a result which such a weather phenomenon is classified as dangerous. The success of the forecast at the regional level depends on the accuracy of the assessment of the synoptical situation. The distribution of gusts at the microscale depends on the input wind speed at the regional scale. Here shows the typical synoptic situation of the formation of the squall. Next slide. In this work, I used the ENVIMET model. It is a 3D non-geostatic microclimate model. The main differences between the ENVIMET and large-scale atmospheric models is the temporal and spatial resolution of the model. The picture shows us a diagram of the interaction between the main predictive variables. Next slide. For the experiment was chosen area on the territory of Moscow State University. The boundaries of the plots are the streets listed on the slide. It's Universitetsky Prospect, Michurinsky Avenue, Lomonosovsky Avenue, and Lebedev Street. The site is a rectangle which including the main buildings of MSU and its department and woody vegetation. All buildings and trees were drawn from a satellite image in the QGIS Geographic Information System. Next. Thank you. The squall on May 29th is one of the strongest events in recent decades. On this day, most of Europe and territory of Russia was occupied by a cyclone. At night, in the morning, and in the first half of the day, Moscow was in the warm sector of the cyclone with high air temperatures. At 16 hours, a cold front passed through Moscow. Aggravated during the period of maximum heating, it caused a complex of dangerous weather phenomenon. This is confirmed by the data of the automatic complex with meteorological automatic complex with per minute registration of the main meteorological values. Its temperature and wind speed. Changes of these parameters, which was interested, are shown on the slide. Next slide, please. Here on the left picture, we can see the advance of the cold front on the city, and on the right slide or right picture, we can see the aftermath of the squall. So now let's move to experiments. Next slide. First, an experiment was carried out to assess the sensitivity of the model to change in input parameters. In the case under study, this parameter is wind directions. Here you can see the specified conditions of this experiment. And next. Yeah. As a result of this first experiment is maps of wind fields. When we comparing these maps, it can be seen that the spatial resolution has a similar structure. So in open areas, we have the high wind speeds, and near the buildings, it's lower. Next slide. The main experiment is to identify hazardous areas at extreme wind speeds. For this experiment, wind fields were built in 4 main directions. At the level of 1.5 meters, the pedestrian zone, and a height of 12.5 meters. As a result, wind maps were obtained. Next slide. This is the maps at the height of 1.5 meters. The maximum wind speeds on this level reach values from 31 to 37 meters per second. The maximum speeds are observed at the southeastern corner of the main buildings of Moscow State University and the southern corner of the building of the physics department of MSU. As a result of analysis, the most dangerous areas in the pedestrian zone are the corners of the building and large open areas. Regarding the direction of the wind, it is impossible to say with certainty which is more dangerous or safer. In any directions, as the excessively high speeds appear in one place or low speeds over the large sections. Next slide. The situation on this danger zone at 12.5 meters is similar to the underlying layer. The highest wind speeds are achieved in open areas and near the corners of the buildings. The differences are characterized by greater values of the wind flow and an increase in open areas. Next. So it's a result of my work. In this work, original calculations were carried out to ensure the wind comfort of a person stay in an urban environment, and I think it is very important for us who live in the cities. And next, please. In the future, it is planned to create the database with different wind maps with different direction of the wind and different speeds. And on its basis, it is planned to create an interactive system of forecasting dangerous wind speeds for the investigated territory of Moscow State University. And in this study, we will use the EnviMet, the QGIS, and another online services, geographic information services. So that's all. Thank you for your attention.
Thanks a lot, Elizaveta. Any comments, any questions? So, Elizaveta, so how do you think, what could you recommend for people during these extreme weather events in big cities? What safety recommendations maybe, or something like this?
First recommendation, stay at home and don't walk during such situations. But if you are outside of the houses, don't stay near wooden vegetation because wind can destroy it, and don't stay near the corners of the buildings. As I say, it's the most dangerous places during the high wind speeds.
Everyone already heard it. Don't stay near the corners during the school events. We have the question from the Alain. Alain, please.
Yes, I would like to first thank the speaker for the speech on this topic. That is quite interesting for us to know. And I would like to ask whether there are some plans to increase the area of the research. Do you plan on increasing the possible wind maps and do research for other areas other than Moscow State University?
With the increase of the area, it is a problem because in the model which I use, we have not so large not so large area which we can simulate, and maybe we will need another model to make such experiments, for example, for districts or parts of the Moscow.
Okay, thank you.
Okay, and I see the question from Andre. Andre, please.
Also have a question.
Okay, I think we will have the time for both questions. Andre was the first, so Andre, your question.
Yes, thank you. So comparing I think it is possible to compare it to breakwater in the ocean that are designed to break the huge waves. Are there any solutions that could possibly slow down the dangerous squalls of wind disrupt them to a level that if they're not completely die down, but at the very least lose much of the speed?
So the vegetation, all types of vegetation in the city can stop the high speeds, and but we don't have so many vegetation, and for example, forests or big parks can protect us, but it's only a small part of our city, so difficult.
Yeah, I guess so. Only so much can be done. Thank you.
Okay, and Paulina.
Elizaveta, in the end of your presentation, you tell us about the prototype of the card. And I have a question. When does this prototype is gonna be planned?
It's I think in 1 or 2 months it will be created. It will create, and there is many technical and other problems with each system of forecasting, but I think we will do it.
Okay, thank you.
Okay.
And Elizaveta, according to the Andre's question, so if we will imagine the building without any corners, will it be more safe in comparison to the real building structure or not?
We need to simulate this in the models. I think buildings without corners is difficult, and here will be another ways where wind speeds can increase.
Okay, thanks a lot, Elizaveta.
Thank you.
And we are moving to the next speaker. The last but not least, Yulia Tolstobrova, with the forecast, I think some ideas about 2050. So it's a very interesting question personally for me, because I plan to be retired for this time, and it's the weather questions will be very important. Julia, the floor is yours.
Thank you, Pavel. So hello, dear colleagues. Let me start by saying thanks to all of you for being here, for the interest in my presentation. My name is Julia, and the purpose of my talk is to give you an idea of how urban climate will change by 2050. So next slide, please. Firstly, a few words about climate forecast for 2050. For example, New York City winters will have the weather of today's Virginia Beach. Damp and cold London will be hot and dry like Barcelona, and wet Seattle will be like dry San Francisco, and finally Washington DC will be more like today's Nashville, but with even greater variation in temperatures and precipitation. Those predictions are according to the first global analysis of how some cities' climate conditions will shift under climate change. We wanted to know what the most conservative estimate of what the climate will be for 520 major cities in 2050, said Tom Crowther, a researcher at Zurich and senior author of the study published in the peer-reviewed science journal PLOS ONE. So the changes that we found are huge, also Crowther says in his interview. Next slide, please. The Crowther Lab in Switzerland created a global data map that pairs one city's future climate conditions with the current ones. For example, Minneapolis in 2050 will be more like Kansas City, with the Minneapolis's warmest month shooting up from around 80 degrees Fahrenheit on average to more than 90 Fahrenheit in 2050. And I've attached a QR code with the interactive map, and you can point your phone camera on the slide and see the researchers' work for yourself. If you want, of course. Yes, so in Europe, for example, summers and winters will get considerably warmer by 2050, with average increases of 3.5 degrees and 4.7 degrees respectively compared with 2000. And there are no good parents or analogs for more than 22% of the world's major cities, those with 1 million or more people currently, researchers found. Yes, and those 115 cities will have unprecedented climate conditions by 2050 compared to what they saw in 2000. The baseline for the study. And however, that doesn't mean that Washington will be hotter than Riyadh or Saudi Arabia today. It means that there is no current match for the wide climate variations in temperatures, seasonality, and precipitation the city will experience. Next slide, please. And now you'll see the two tables that show the extent of climate changes in major cities of the world by 2050. So I will explain it. I will try to explain it now. Cities predicted to have climates that no major city had experienced before are colored in red, mostly within the tropics. And cities for which future climate conditions reflect current conditions in other major cities of the world are shown in green. Moreover, the size of the dots represents the magnitude of change between current and future climate conditions. And next slide, please. Cities shifting toward the equator are colored with the blue gradient, also mostly outside the tropics, while cities shifting away from the equator are colored with the yellow to red gradient, also mostly within the tropics. Next slide, please. For the analysis, Zurich extracted 19 current and future bioclimatic variables from the coordinates of 520 cities around the world, consisting of major administrative capitals and cities with over 1 million inhabitants. And this variables reflect the variability in temperature, precipitation, as well as the monthly trends, the annual average. And future conditions for the year 2050 were calculated based on the representative concentration pathway, which represents the optimistic scenario where the implementation of mitigation policies will have stabilized the CO2 emissions by the mid-year, and the mean global temperature will have increased by 14 degrees. And therefore, the results represent the best case scenario. The next slide, please. The analysis shows that 77% of the cities around the world will experience a striking change of climate conditions, with 22% encountering conditions that currently don't exist. And the most dramatic shift will occur in cities in northern latitudes, with the climate in 2050 resembling today's climate of cities over 100 kilometers to the south. In Europe specifically, cities will be 3.5 degrees warm in summer and 4.7 degrees in winter. And this means that London, for example, will resemble today's Barcelona, Moscow today's Sofia, Stockholm today's Vienna, Seattle, San Francisco, and for example, Madrid will resemble today's Marrakesh. Next slide, please. Tropical regions will experience smaller changes in temperature, but significant shifts in precipitation, with the wettest month being 5% wetter and the driest month 14% drier. Overall, the tropics will become drier and droughts more severe. However, these predictions are to be considered the base case and contain a high proportion of uncertainty, as out of the 22% of cities that will experience novel climate conditions, 64% are located in the tropics. Next slide, please. Generally speaking, the researchers observed changes towards less temperature seasonality, with higher maximal and minimal temperatures during the year, as well as higher precipitation seasonality, with higher precipitation in the wettest but lower in the driest month. The daily difference between cities' maximum and minimum temperatures will increase. In brief, by 2050, cities of the world will have become hotter, in particular during the winter and the summer. Wet seasons will be wetter and dry seasons will be dry. Next slide, please. The researchers believe that it is through the comparison with the current cities and there are no struggles with the climate conditions that the need to act becomes tangible. In 2008, for example, Barcelona experienced extreme drought with severe implications on the well-being of its population, and the consequent need to import nearly 22 million euros on drinking water. In 2017, the Mayor of London has factored drought considerations into the city's environmental strategy aims for 2050. Even though the analysis contains uncertainties and the predictions may change as the system models are refined, it may provide the context to facilitate the development of more targeted climate strategies. Next slide, please. Human activities from pollution to overpollution are driving the Earth's temperature, fundamentally changing the world around us. And climate change has consequences for our oceans, our weather, our food sources, our health, and not very good consequences. Yes, and next slide, please. While the rapid rate of climate change is caused by humans, humans are also the ones who can combat it. And if we work to replace fossil fuels with the renewable energy sources like solar and wind, which don't produce greenhouse gas emissions, we might still be able to prevent some of the worst effects of climate change. So next slide, please. Well, thank you all for your attention. Now I'm ready to ask your questions, if you have any.
Yeah, thanks a lot, Julia. And I think I see Alain now is ready for questions.
Yes, I would like to thank you for the speech. And if we could go some slides back to the slide with the type of comparisons between the cities in different climate areas that had particular, yes, this one, yeah. It has a composite climate metric, which seems like a good thing to evaluate the climate change. I have a question. How is it calculated?
Well, so Zurich extracted 19 current and future bioclimatic variables from the coordinates of 520 cities, and then they compare the climates in different years, and after this they made a decision about the research, and yes, I believe something like that.
The point of my interest is which variables exactly are counted here. Is this metric a subjective one or an objective one? Can I, like a user, calculate it? How can I obtain the value?
I don't think that you can calculate it by yourself, but there is no such information about what variables they chose, unfortunately.
Okay, thank you.
Yes.
Any other questions?
Yes.
Yeah.
I have one. So, Yulia, in your opinion, how can people prevent the worst effects of climate change that you point out?
It's a very interesting question. Thank you. I believe that even the little things can make a big difference. For example, every time you turn off the water, brushing your teeth, you are doing something really good. And walking and biking are also the ways to prevent some bad consequences, to reduce greenhouse gases. And also you can use reusable bags to the grocery, for example. You can use you can avoid using disposable plates and spoons, cups, they create huge amounts of waste. And another way is to volunteer, of course, planting trees or cleaning the territory, at least near the place you live. Well, yes, there are a lot of such small things that can make sense.
Okay, thank you for your answer.
Very good question from Andrew about the different hemispheres. Andrew?
Of course. Thank you. Thank you very much, Julia. The question is, judging by the maps in the first slides, we can observe that most of the cities discussed are located in the northern hemisphere. The question is, these are the cities that are going to be affected the most, but what are the underlying reasons for that? The one I personally can see is that the northern hemisphere is just generally more populated, and in the southern lives only 1/10, I believe, proportion of the Earth population. But is it true? Is my assumption true?
Girls, can you turn onto this slide that Andrei is talking about? I believe it's the first one, yes?
Oh yeah, the first few ones.
These ones. The second, I believe. Yes, if I understood you right, you are talking about the population of these cities, and could you repeat your last question?
Oh, sure. Is the southern hemisphere less affected while generally it is less populated?
It's a very difficult question, I believe. I haven't thought about it earlier. Well, I will surely look up to it later after our discussion, because now I can't answer it, unfortunately. Yeah. I'm sorry.
No problem, Julia.
Well, I will help a bit to Julia.
Thank you.
And Andrew, the interesting point is that in Southern Hemisphere, normally you have not very good assumptions for different cities. It's I think the first idea. And the second one, that affect this urban climate, the climate change and the climate warming region, I mean, is most intensive close to the poles, to the North Pole and to the South Pole. And according to the number of the continents and the percents of the continental and the ocean in different hemispheres is not the same. The northern hemisphere is normally more populated, and also the warmer than the southern one. That's why the affecting will be not the same for different cities. And of course, if you can find I think maybe the new city climate for the Moscow to Sofia, but I guess it will be also much more cheaper to have a trip, because you don't need to take a plane. So the Sofia will come to Moscow in only the 30 years. It will be maybe much more difficult to find such cities for the cities of the southern hemisphere. So because there are the total number of cities in the southern hemisphere is not so big as in northern one. So it's the second thought. Okay, so
excuse me, and May I a follow-up inquiry? And do the oceans play their part here? I mean that the southern continents are surrounded by vast areas of water, while in the north we have mostly land.
Yes, I believe that something, of course, depends on the oceans that surround the continents, but I don't know how exactly.
It's okay, Yulia. I'm sorry, I was addressing the question to Pavel.
Mm-hmm.
Of course, but if you will find according to my previous answer, so in total, I think the total percent of the cities situated near the seaboard in the southern hemisphere will be much more bigger, because so the southern hemisphere was according historically derived by the ships. So you know very good the history. You know good the history of the Australia, of the New Zealand, and so on. So I think in total Australia, finding the big cities that situated in the central area. So I think it's about the maybe 12 or 30 cities, and compare it to the inland cities in Asia, for example, to the Russian one and so on. I think you are definitely right in your proposition.
Thank you for answering. Appreciate it.
It's Julia. It's not who already choose this very good paper of the Thomas from the ETH. So you know that ETH is the most powerful university from the continental Europe now. So if we will not take into account the US and the UK universities, so ETH will be the number one, for example. That's why thanks to Julia for the good choice.
Thank you.
So we have already seen and heard 6 marvelous reports, and I think it's very good for our session. Now we have about 5 minutes for voting. So if you want to vote for someone, so you can use the link in our chat. So you have the possibility to vote 2 times, one time for the person from the Moscow State University, and the second one to the RANHIX. So maybe some remarks. If someone wants to say something, any ideas, any replies, maybe Irina, maybe you want to say something? Yes, why not?
Yeah, I was just impressed with this session because I'm very grateful to you, Pavel, first of all, and to your students from the Moscow State University. Moscow State University is my alma mater, so I'm double proud of your eagerness to participate, because it's a very unusual session. It's for the first time we're running anything like that, and I want to continue this. Now will become a tradition, because the idea of this conference is how, based on expert knowledge and trust to experts, the managerial decisions should be made, and vice versa, how the scientists, natural science or this applied science and fundamental science have to be insistent for the, how the consequences of their implications of their research should be, converted into the managerial decisions. So who doesn't remember, the motto of our conference was that how the best in people, meaning the integrity, scientific honesty, things like that, right, will make the worst of times livable. And now I see these young people who will live probably, like Yulia said, up to 2050 to see what will happen to how these prospects will come true or not, or whatever. So today they saw how they can communicate, how they can understand the third, because the people from Moscow University, they took their project, their professional project, their scientific research, and adapted it for the understanding of people from management school and vice versa. The students from management school, they looked into, they probably long ago forgot their physics or chemistry or whatever, and they looked into this sphere of urban climate, which is paramount important for all of us in the future. And so they tried to get to understand this. I'm very proud of Andrei, who probably looks he has a profound knowledge of all these matters, understanding, Yulia as well, and other students, all of you. Thank you very much, Paulina and Alena, and you, master students from Moscow University, or baccalaureate. Master students?
It depends.
It depends. Master students, who else? Probably looking for a PhD, yes, studying for the PhD degree, right?
We hope so. We hope so.
We hope so.
Right. So, yes.
Thank you very much. That's why. So it was our first time we are doing this. That's why we decided, as Pavel said, to have two different voting for two parts of our speaking audience. But probably in the future we'll come up with some other nominations, evaluating not only your professional knowledge, but also your ability to adjust or to adapt or to be agile and flexible and understand each other. Right, you've done a great job. Thank you. Now the floor goes to Lisa, who will announce the results of the voting and what will come of it.
Yes, so hi everyone. My name is Lisa. I'm coordinator and expert liaison of Student Gaidar 2021 conference. Probably some of you knows me. And nice to meet you, Pavel, and the students of Moscow State University. So it was a great pleasure. It was so interesting to listen to your presentations. So let me expert the results of the best speaker from Ranepa. So give me a sec, please. So let me share my screen for that. So the best speaker is Shanov Andrei. So congratulations, Andrei. We are very proud of you today. Good for you.
Thank you. Thank you very much. I'm honored to receive such kind words.
So give me a sec to download the results of the second nominations for Moscow State University students. So just a few moments. Mm-hmm. So the first place goes to Alan Kaspanov. Alan, congratulations.
Thank you very much.
So thank you very much for this session. It was a pleasure to me be a participant, be an audience. So I hope that you will had some fun, and I'm sure that this discussion was a great experience for you. So have a lovely evening. So thank you.
And we'll continue. We'll continue.
Yeah, I will leave. I mean, I will leave now. That's why I say goodbye to you and wish you a good time. So,
yeah. Okay, so I hope all of you will take part in the conference probably next year, but probably in summer, if everything is okay. And we will probably have the summer school, and I will be very happy if some of you will join us in this experience. Pavel, thank you very, very much. I know that Pavel is one of the most outstanding climatologists, meteorologists of the time, and the head meteorologist of the observatory of the Moscow University. Really flattering to have you today. Thank you very much.
Thanks a lot, Irina. I was doing my job, like people say in the Hollywood movies. But I would like to say a few words for concluding our I'm very happy that our session was so impressive, especially for me, because the different session can have the different results, and the people can be not so involved in interference, not so involved in communication. But I think our first idea to connect the people from the urban climatology from one side and the students from the decision maker, the future decision makers from other side, I think we can conclude it as successful. And I think not speaking about this kind of awards, but I think the main result is that you already had the possibility to hear something new from the people with a different background. I think in future, so it will be very important for both sides to impress and to know how the way of meaning, the way of thinking of the people with different backgrounds. So thanks you all for these 2 hours. And I think so maybe sometimes we will meet on different sessions. Thanks to Irina, thanks to Elizaveta for the idea and technical maintaining of this kind of session. So, and
I have one proposal.
This evening.
I have one proposal, Pavel.
Yes, Irina.
I want to ask all the speakers and even the audience who is still with us. So it's Saturday night already. People are leaving, of course, and we're starting 9 in the morning. Probably all of you can open your cameras, switch on your cameras. And if
you want to have the common print screen?
Print screen, yes.
Yeah, okay. Now
and the audience as well, because there are still people in the audience, please.
Everyone, please open your camera.
Your cameras, are there? Is there anybody else?
Oh, Paulina.
Polina, Elena Gubanova, Elena Novikova, Victoria Bernstein. Could you please open your cameras? Polina, wonderful hair. Julia, beauties, all of you young ladies. And while people are doing this, Polina Vorotilova, you are sitting behind, what is behind the meteorological cabin or something like that, right? Which looks like it, right?
Yes.
Yes, it's professional sign. Okay. So make the print screen. Thank you. So?
Cheese. So, Irina, everything is fine. The pictures
fine. We will inform you when you can see the recording on the student Gaidar site, probably. Yes, because I probably do remember that, I don't know, but it is also in the Facebook of Student Gaidar and in the YouTube channel of Student Gaidar. It was all broadcasted to these social networks. Right. So what we did to each other today, it was piece of enlightenment. And this future of enlightenment in Russia is now is disputable, but today we did it. Okay, thank you.
Thanks a lot to everyone.
Bye-bye. Have a nice evening and nice weekend or what is the rest of it. Bye-bye.
Thank you all the speakers for your involvement and enthusiasm. Have a nice weekend, everyone.
Please write your references to the WhatsApp group. Write your references, right? We will publish them in the site of the Moscow State University, probably Geographical Department, and then the Ranepa. Please, we'll publish the news and announce the results. Okay. Bye-bye. And all of you, we will let you know when you will have a chance to get your electronic certificates. And Pavel, I remember about the official list, yes? Official invitation or something, I'll do it tonight.
Okay, thanks a lot.
Bye-bye.